On the chart, right, what questions did you want to see you go over, have questions about?
Wait, hold on. Which ones?
No.
Okay. I'm actually very confused. 4 and
I think that was supposed to be 5 in my last class, but I thought
you can do it for us, and we can also have our 3 and then you can give us theirs.
Yeah.
I was
I
trying
mean,
to.
you could go back and watch the video to watch things. But, okay, let's do 1 and 4 and 5.
Yes. I like that idea.
Okay. 1 and 4 and 5 can be done in decimals. So we typed in these ordered pairs. And then typed in our y equals mx plus b. We can add in all the signers, change the slope to whatever the slope is here. We count it's up 2 over 1, so there's 2. And then move the b until it goes through those points. So b was your answer there. Y equals 2x minus 3. You did that in Desmos, make sure you write use Desmos. Questions on that one? Number 4. If you put in both sides, nothing happens. And I know it's not going to be A or B because I don't see a line at 0 or a line at -5. So it's either no solution or infinitely many. We're going to take away half of this and put it in another line. And they overlap, so infinitely many.
So if it's 0 equals 0,
If it's 0 equals 0, it's infinite. Sorry, I did turn a second process for a second. And then number 5. For this, I see that this is a solid line. It says 2, but I really only see 1. We'll do the one that's obvious and then I'll find out. So, solid line, starting at 3, the slope is 1, and shaded above that would be D. I think one of the other ones are going to match that. And if you put that in Desmos, it would overlap. You might want to see that in Desmos. Would he also look? Because there's only 2. Okay, because this one's close. The line is the same, but the shade is below, not above. Why?
I already know the answer for it, but like, is number 3A? So like, can you do something?
Yeah,
Number 3A.
I changed my answer to A. You could be wrong. The number one.
Kid.
Any other questions on 5?
I'll change your decision. If it's wrong.
Next class will be our last shark bite of the year.
Wait, what'd you say?
Next class will be our last shark bite of the year.
For that, I'm gonna ask you what gets that, and I don't even like them.
Alright, look at the notes on your desk. Alright, this is going to be some review of what we talked about last class, but also domain and range. We talked about that previously, but now we're just going to talk about it with all different functions, graphs. So, as a reminder, our domain is what? The x, range, and when we talk about the domain and range, the graph, it depends on what type of graph it is that will help us determine how we write the domain and range. So if we have points, like random points along the graph, that's discrete. Yes.
Oh, that is not like what you spell discrete. I thought it was 2 E's.
I don't know.
How do you spell discrete? So now
You were wearing 2 E's. Oh no, in math, it's not like that.
So it's 2
Okay.
It looks weird with 2 E's, but it looks weird separate.
Yeah. Okay, and then if we have functions with lines or continuous curves, those are continuous. I didn't mean to say continuous. So like all of your lines, all of your quadratic functions, all of your exponential functions, those are all continuous functions. This next part is just review so that you can put all of this together. They have points that cross or touch the x or y-axis, so they may have a y-intercept or an x-intercept. And then for that second part, x-intercept is also known as a 0, because if you put it in, if you substitute it in, it would make the function equal to 0. Also known as a solution or a root, because it makes the equation for the function true. So the first couple examples, we're going to determine just the domain and range, and is it a function or not, and then after that we'll find x and y-intercepts also, just as extra review. So we first have to determine, is this a discrete or a continuous function? Because there are a bunch of random points. And then for the domain and range of a discrete function, just like when we're writing the relations, you're going to write them in curly brackets, least to greatest, with no repeats. So what would the furthest point to the left be? -4. Keep going. -1, 1, 3. And that would be our domain. Then we're going to do the same thing for the range, but lowest to highest. What would that be? Keep going. 2, 3, 2, 3, 4, You don't put in repeats. So that would be our domain, that would be our range. Is this a function? Yes. Yes. I could draw vertical lines with all the points, or I could look at the x values. Each one has its own y value. So yes. Questions there? Go on to the next one. So then let's do the same thing for this one. What would the domain of, sorry, is this discrete or continuous?
Yes.
What would the domain of this be?
Negative 6, negative 3, 2, and 4.
Okay, and then the range?
Negative 1, negative 4, then
Negative 8, negative 4, negative 3. Next. This is supposed to be a D.
it looks like.
Alright, is this a function?
No.
No. Because it wouldn't pass a vertical line. Any questions so far?
No.
Now we're going to deal with some continuous functions. I said that, so everyone saw this. And when we write this, there's a certain format that we have to write this in. We're going to start off writing this with curly brackets. Domain is x, so you're going to write x, and then there's a vertical line. And then we're looking at where does it start and where does it end. If you want to draw in like lines to show that, you could do that.
So what do these lines mean? The X with the curly bracket.
When we finish it, I'll read it off of it. Where does it start?
-5,
-5,
-3,
and we're just going to put start to end. So it starts at -5, then you're always going to have less than or less than or equal to. These are closed, so less than or equal to. X goes in the middle, less than or equal to again. What's the furthest point to the right? 6. Close it.
I'm so confused.
So this is just the format of how it's written in set builder notation.
why is less than or equal to not just less than?
It depends on the point. So these ones are closed, so they're equal to. But if they were open, it'd be this less than. So this reads x such that -5 is less than or equal to x, which is less than or equal to 6, which means everything between those two numbers is your domain. Now, we know that interval notation, using our square brackets, since these are both closed, would start at -5 and end at 6. You need to know both, but more than likely on the SOL you'll see set builders than intervals. You have to be able to recognize them both. Or
It's kind of like give a set and then we have to like choose a graph of what matches that.
there are so many different possibilities for that. Do you have any other questions on that before we do the range? But once you figure out the formula, how you start to write it, that part is just the same over and over and over. So you start off the same way, curly bracket, but this is now y line. And you're looking lowest to highest. 2 to 4. So it would be -3 less than or equal to y is less than or equal to 4. Or in interval notation, -3. So anytime you have a continuous function and you have endpoints, stopping points, starting points, it's going to look like this.
Is it always less than or equal to?
Yes. Or less than, depending on the points.
So if it's open, it's just less than, if it's closed, less than.
Yes.
As long as it's always less than, I got this.
Now, the next part is just review. What are the x-intercepts? -4 and 2. Write those as ordered pairs. And the y-intercept? smaller than that? Sure. I don't know if mine looks the same as yours does.
Yeah, no. Yeah, no, it does.
So, sure, negative 1/2. 0, negative 1.5. Is this a function? Yes.
I'm sure.
If you did the vertical line test, it would only cross at one place. We'll do the next one when we get back. You can draw in the furthest point to the left lines and furthest point to the right lines and the lowest and highest if you want. We're going to start off curly bracket x line. What's our furthest point to the left? -4. So -4 less than or equal to x less than or equal to furthest point to the right. And curly brackets in interval notation, square brackets, -4 to 5. Range, we'll get your lowest to highest. -6, how would we continue writing that?
Less than or equal to x, y less than or equal to constant 6.
And then in interval notation, that would be -6 to 6. Okay. X-intercepts. Have any x-intercepts?
They're very close to the one.
Yeah, so I would say you can put it in the middle, maybe half. And then the y-intercept, same thing, like -half. Is this a function? Yes. Yes. It passes the vertical axis. I want you to try the rectangular one on the next page, and then we're going to move on to a different type of continuous. So I'll give you a couple minutes to do that. What would the domain look like? Start it from the beginning.
Curly bracket x, vertical line -5 less than or equal to x less than or equal to 4. Curly bracket, and then
Okay,
square
start.
bracket.
Pause. So do you have any questions about the domain? And now the range.
Curly bracket y, vertical line -5 less than or equal to x less than or equal to 6. Curly bracket.
Y, but not X, but everything else was good. Did we have x-intercepts? Where?
-5.
-5, 0, and 4, 0. Y-intercepts?
0, 6, 0, -5,
0, 6, and what was that one?
-5.
Is this a function? So anytime you have starting and stopping points or endpoints, it'll look like the ones we just did. Now when you have arrows, it's a little different. So this is a quadratic. We talked about the domain range of a quadratic, so it will be similar to what we've seen before. But just as a refresher, domain, we're looking at our x values and we have to imagine this, that this keeps going off the graph, down and left forever and ever in that direction. So where would that start?
It goes
furthest point to the left.
Oh, sorry, negative infinity.
So it starts at negative infinity, and then it's going to do the same thing on the other side. And anytime it goes to negative and positive infinity, we start writing it the same way, curly bracket, x such that we're the line. But then you write x is an element of this weird e, all real numbers. Or all real numbers. They mean the same thing, just written in two different formats. Your range, if I'm looking lowest to highest, what's your lowest point here? Negative infinity and highest. It does have a highest, but it doesn't have a lowest. So that would be everything below 3. So again, starts off the same way, but we're going to use this, our inequalities. Y is less than or equal to 3, and that's it. So anytime you have arrows, you're either going to be using all real numbers, or it's going to be greater than or less than some number. Or questions about those? Do we have x-intercepts? If you want to put them at 2 and negative 2, that's fine. Mine are a little off, so I'm going to make up something that would make more sense for mine. Again, if you put 2 and negative 2, that's also fine. Y-intercepts? Y-intercepts? 1. So that would be 0, 3. Is this a function? Yes. All quadratic are functions. If your quadratic is turned sideways, it's one not a quadratic and it's not a function. Questions on how we find domain range with arrows? Try the next one. So think about furthest left and furthest right. What would the domain of those be? So how would I write that in set over notation? X, you could say E, R. Or in general, all real numbers. What about your range?
Y vertical line, Y here, here,
It's the same. Depending on the function, they may both be the same, they may both be different. All of your lines or linear functions have domain and range of all real numbers because they keep going on forever and ever. Maxwell's equation.
Wait, so for it's like the curve one, it's gonna be different?
Yes, depending on the curve. So this will be different. The quadratic will be different than a linear function. But some of your other curves will be different than these. X-intercept. Or 0. Y-intercept. 0, 2. Is this a function? Yes. All of your linear functions will be functions unless it's a vertical function, because it fails the vertical line. I want you to try this next one. And I'll give you a couple minutes to do that. Or well, figure out. Anyone have the domain answer?
Yes, it's going to be curly bracket X vertical line, X is greater than or equal to 0.
So you're still looking left to right. Furthest point to the left would be at 0, and it keeps going to the right. So everything greater than or equal to 0. What about the range? This keeps going down and up because it's going both is going to be all real numbers. Questions on those two before we do the rest?
Do not throw things.
Bad. It was right by space. What are you talking about? Is it?
I swear I just said stop throwing things.
And then he hit right separately.
Well, Maxwell. X-intercepts, what are they? 0. Y-intercepts? Is this a function? Look at the practice problems on the next couple pages. Are there any you want to see, do, go over, have questions about? Max.
3 and 2.
This one? Okay. 3 and 2?
Yep.
Okay. And this one? Okay. Any others on that page, on the next page, on the page after that?
Like a circle.
Okay. Okay. And then we're also going to do on that first page. Alright, so for this first one, looking left and right, what's your furthest point to the left? What's your furthest point to the right? This keeps going down and left and up and right. So your domain is going to be all numbers. What about your range? What would your range be?
The same thing.
Yes, all our numbers. X-intercepts?
-3 and 3.
And then y-intercepts?
1.9.
Is this a function?
Yeah.
Yes, it passes an orthogonal. Questions on that one before we do this next one? Okay. What would the domain of this one be? What were you going to say, Max? Okay, but in set builder notation,
Is it the greater than, is it the less than? Okay, then
The E.
the weird ER.
all real numbers. So when you're answering that question, you can say the domain is all real numbers, but then the set builder notation of it is this. The interval notation is negative infinity to positive infinity.
Huh?
Which part were you confused on?
The whole thing.
The domain is all real numbers. Set builder notation is what we just wrote. Interval notation is negative infinity.
Okay, so you just did all of them.
Wait, how do you know if it's not all this?
All have arrows going in both directions.
So if they're both going down, it's not.
Correct, because then it doesn't go up and down. Alright, range. Does that go on forever and ever in both directions?
Yes.
No.
No. Why not?
So it has a lowest point and it has a highest point. Then it has stopping points. write this with the two numbers, -6 less than or equal to y less than or equal to 2. Lady, stop talking, please.
Isn't that negative?
Yes. So sometimes they can be different. It depends on the function, on the graph. What are the x-intercepts here? Put an A, don't put 0 or none. For the y-intercepts, so that would be 0, -2, 0, -4, and 0, -6. Is this a function?
I have a question. So how come for this one, it's like infinity?
So this one we're looking left and right. The furthest left. This keeps going down and left. This keeps going up and right. Lowest and highest, this keeps going down, this keeps going up. But for this one, domain, I see this keeps going left, this keeps going right. But for range, it's only here. But if it was tilted, then it would be. Alright, we're just going to do the domain and range of the next one. You can figure out the x, y-intercepts and if it's a function or not. What would the domain be?
The real numbers.
Total, yes.
And then as for the line to the fact that we're in the real number.
Yes. But for the range, does it move?
No.
So that means when you write it, it's just going to be y equals. Y equals what? So if you have a line that does not move, it's just x or y equals whatever that is. Go on to the circle one. And then you guys will have to
This one.
Alright, for the domain, how would we write that?
Curly bracket. X. Vertical line. X. No. No. X. No. Then I can
Negative
negative 1.
Less than 1.
Ah, I got it. X less than or equal
You have to be able to go back and forth between the two. Which ones have all real numbers or greater than this a number or less than this a number, or which ones have both at any points have both. What would the range be?
Any number less, any number greater than -1. So it's just gonna be y vertical line -1 less than or equal to 1 less than or equal to 6.
Close, but it's 7.
I can't read the numbers.
Your oscillograms, you can zoom in and whatnot. Usually circles, they have the same numbers, but sometimes that's not the case, depends on where the circle is placed. Almost, we're almost there. X-intercepts. Mine are like in between, but you can put them wherever yours fall. Y-intercepts. Mine's not 5. Mine's in between, but if yours falls on it, that's great for that. Wherever it falls. And then have any questions in general on how we find domain and name from any function. So the delta math on this is not due until next week, but you guys do have two that are due tomorrow, the relations and functions and the radical operations. You guys have your test tab SWL that's due on Monday. Your 8-well packet, you can continue working on that. Your math gap SWL packet, you can keep working on that. JLabs, the practice quizzes, past delta math, practice and details. One of those things